control plane of Kubernetes has a bunch of components. And you're going to understand in a bit why I'm talking about this. But the kind of four main components that you need to run Kubernetes are the API server, the controller manager, the scheduler, and etcd. So the API server is the thing that you talk to when you do kubectl or use a dashboard. That's sort of like the main point of entry to Kubernetes itself. The controller manager, I'm going to talk about controllers in a bit and operators, but essentially there are many bits of pieces of code inside Kubernetes that makes Kubernetes work the way it works. And we call those pieces of code usually operators. And the role of operators is to turn the desired state into a current state. So when you are interacting with Kubernetes, you're not writing code. You write configuration, which is in the form of YAML. You send that configuration to the cluster, and then there is a piece of code that will look at your configuration and make it happen, right? The scheduler is the thing that does scheduling, so it kind of decides where pods are going to be placed. And etcd is sort of like it's a database. So etcd is a key value database. It's a non-SQL database, and it's used to store the current state of the cluster. So whatever is in the cluster, nodes, pods, deployments, services, all that stuff is stored in etcd. And why is it key value? Because YAML is key value. Pretty much everything in YAML is key value. And Kubernetes have been built on these three main kind of philosophical implementations. It is declarative. So you express intent, not action. You don't write a script, you write configuration, and that configuration is considered an intent. You are intending to deploy something. It's extensible. So the same way those bits and pieces of code I talked about, we call operators. There are some that ship or come out of the box, but you can also build your own operator and run it in the cluster. And it's universal. It uses a common language to describe everything, and pretty much everything Kubernetes is a resource. So case in point, when you deploy stuff in Kubernetes, it is considered a resource. And for those of you who are web developers or have some web development background, it is considered a resource from even a web API point of view. So you think if you have used REST before, in REST, everything is a resource, right? And so when you are deploying something into Kubernetes, you are sending a YAML file to the API server, which stores it in etcd using a push command. Or a put or a post, essentially. So you send a post request to the API server, and then in that post request, there is a resource. Same thing when you do a get, same thing when you do a list, etc., etc. So here is an example. This is an example of a pod. We are deploying a pod in a namespace called default. I'm looking at the left, by the way, because that's where my slides are. It's not because I don't want to look at the camera. And so you see this YAML file describes a pod that has a name called Explorer stored in a namespace called default. It has a bunch of labels and it has a bunch of details. This is what we call a desired state. This is what I desire, I intend to deploy. You send that to the cluster. The cluster will store that, and then an operator, an object, a piece of code will get notified by the API server that actually, if you have looked at Kubernetes, there is this thing called watch. And watch is the mechanism by which a controller can tell the API server, notify me when this kind of objects get created or deleted, right? It will get notified, and then it will go, okay, the desired state is to deploy a pod, but right now there is no pod, so I'm just going to go ahead and deploy it. And it will, write a bunch of code, run a bunch of code to make that deployment happen. Which means what does that mean for us, and what does that mean for KRO? This means you actually can extend the capabilities of Kubernetes, but by creating your own custom resource. And we have a name for that in Kubernetes. We call that a CRD, a custom resource definition. So the same way there is a pod, and there is a deployment, and there is a replica set, and stateful sets, and all these things, you can actually create your own object, a made-up object database, right? And so this is typically how a custom resource definition looks like. So this is a very short custom resource definition, but let's just look at it together. We are defining a custom resource definition that we are calling counters, right? It is namespace scoped, which means this object can only be created in a specific namespace. Kubernetes has two distinguishing. You can have cluster-wide objects and namespace-specific objects. And then there is a schema. And the schema tells us that this particular object called counter has a field called um, value, and that this value field is of type integer, right? So once we create this custom resource definition and then create it in the cluster, what this will do is that it will make Kubernetes aware that we can create an object called counter that has a value which is of type integer. And that's what we do next usually. We just go ahead and create an instance of that object called counter, give it a name, because obviously things have to be named, and then give it a value of 42 in this case, right? And this is essentially what happens when you post the object. You're like sending a post with a bunch of parameters, and the parameters are essentially what's in the schema of that custom resource definition, right? Now, doing just this in a Kubernetes cluster is pretty useless. This is not going to do anything. You would just be basically storing random objects into etcd, and you're like doing just this. You're just turning Kubernetes into a very expensive database, which is useless. That's where controllers come into play. Typically, when you create a custom resource definition, what you're trying to do is you're trying to make it simpler for somebody else or for yourself to create things. So you create a custom resource definition that describe an object, and later on, people create those objects, and then when those objects get created, a piece of code that you write will have to go and make that object happen, right? Remember, intent versus you express intent and then something make that intent happen. You send Kubernetes a wish, and your wish becomes a reality. That's where controllers come into play. So controllers are pieces of code you write that will go register themselves to the API server and tell the API server, I am monitoring those objects called counters. And when a new object called counter gets created, please notify me. And so the combination of Kubernetes, CRDs, and operators is what we do basically to expand Kubernetes itself beyond the objects that it supports natively, like deployments and services. Building operators is kind of tedious. There are tools to do that, like KubeBuilder and Kudo, but it's not simple. Here is an example of what we can do with the combination of operators and CRDs. We can actually use Kubernetes as a way to create resources in cloud. So almost all cloud providers have APIs that allows you to call to create an object, a virtual machine, a bucket, something, right? And so what we can do is we can create a CRD that describes an object, a cloud resource, right? And then create an operator that will monitor those cloud resources. And when this cloud resource gets created, that operator will get triggered and call the cloud API to provision the resource for us. So there are several ways we could do this. The most common tool that everybody knows is Crossplane, which is a multi-cloud open source tool. But cloud providers have their own tools. We at Google have something called KCC, Kubernetes Config Connector. AWS has ACK, and Azure has ASO. And of course, you can either use any of these three tools, or you can build your own, right? As long as you know how to talk to an API, you can build your own. Now, here is an example of something you can do with this KCC. Again, I'm talking about KCC because it's the only tool I know, because that's what we have at Google, but all the other tools work the same way. So this is not a product pitch. I don't care. I mean, I'm not trying to pitch Google Cloud to you. I'm just giving you an example. So you can, for example, make it possible for developers to create Cloud SQL instances using an object Cloud SQL interface. So you will have to create that CRD and install it, or use KCC in this case. And then people can just later on, developer one, create a Cloud SQL object using the object called Cloud SQL, or developer two create a bucket using the object called GCS bucket. And those get triggered, or those will trigger KCC itself, which is the operator that will go and provision all of these tools for you. But as I said, writing and maintaining CRDs and operators can be challenging. There are many, many problems that could occur if you don't do it properly. Probably the most common ones is that operators can sometimes overload the API server if they're not designed properly. CRDs could stored in etcd could actually cause etcd to run out of storage, and there is a bunch of other problems that could occur, but just for you to be aware. Now, a bunch of people sit down and decided, or asked this question: what if we can make this easier? And that's where KRO comes into play. So KRO helps you create and manage CRDs and leverage existing operators to make it easier for your users to use and interact with objects in Kubernetes. Let me show you an example. Hopefully, you're able to see my slides, or my IDE. Let me know in the chat if it's too small, and I can make it a little bit bigger. But let's take a very simple example. Let's say I want to deploy an application in Kubernetes and make it available outside the cluster. So deploy a load balancer in front of it. I will need at least 3 objects. I need a deployment, right? I need a service, and then I need an ingress. And if you have done deployments in Kubernetes, you know that these are probably the 3 minimum things you need to deploy something into Kubernetes. But the reality, like, people use more than just these 3 objects. You might have config maps. You might have secrets. You might have horizontal pod autoscaler, vertical pod autoscalers, many types of objects. But just to make it simple, let's say that these are the 3 minimum objects you need to deploy an application. Now, doing this once or twice, it's simple. If you have to deploy this application many times, you will have to copy paste this and modify certain values. And that's where tools like KPT or Customize come into play, because KPT or Customize allows you to templatize these objects so that instead of just copy pasting the entire object and just changing 2-3 things to deploy it, you have a simpler file that allows you to just input the values you want to set, and then it will use the template to generate the final object, right? Helm Helm is another tool that is also very known for being able to do this, but Helm has the added feature of having a marketplace. So you can use Helm to build your own templates and then share them, and then other people use them. Now, what KRO allows you to do is it allows you to actually simplify all of this. So KRO has this thing called resource graph definition. So a resource graph definition is an object that allows us to define a resource, like a CRD, essentially, and then define what happens with that resource gets created, right? So this is an example where we have a simple object. I called it simple RGD, resource graph definition. And I have a schema section. And in the schema section, I say that my object is of type application. It has 3 parameters. It has a name, it has an image, and it has an ingress. And I'm also setting some default values, right? Cool. I also say I want to have the status, and I'm going to explain this in a second. In the resources definition, we basically define when an object of type application gets created, what happens. Well, we're going to go ahead and create a deployment. And in the name of the deployment, we're just going to pick the name that was set in the schema. So this $schema.spec.name is essentially this value here. And then, this is your standard deployment, blah, blah, blah. So we have a service, same thing. And then we have an ingress, same thing. We can also get things like label selectors. So I can, this is something called cell, common expression language. Using this cell, I can actually get the deployment, which is this one here, grab the spec, grab the selector, and grab the match labels, and use that to set my selector in the service. And doing it this way will actually create a dependency between the service and the deployment. The dependency will be that in order to deploy the service, I need this value, and I cannot get this value until the deployment is created. So it will create the deployment first, then create the service after. It uses DAG to figure out the dependency between objects and the order in which it will create the objects. So once I have created this and sent it to the cluster, now if I do a kubectl get CRD, so custom resource definition, and grep on application, I will notice that I have a CRD here called applications, right? So this is a CRD that was created when I created this simple resource graph definition using these applications. And you can see that it has .kro.runtime. So just defining a schema created a CRD for me automatically. Then now I can go ahead and check that, because I already deployed this, so I can do a kubectl get applications. I will have this thing called my app. So how did I deploy this? Well, I just simply created an instance of type application, called it my app, and provided the values in the spec. So the name, the ingress, and the image. So if I describe this object here called my-app, I will see that this is managed by a controller called KRO. There is a bunch of labels in here. And I should see in the status that is reconciliation succeeded, status true. You remember this status field here that I defined in the resource graph definition? Well, what I did is I basically said, I want two statuses. I want a deployment conditions and I want available replicas. And the value of deployment application conditions will be coming from deployment.status.conditions. The second one will be coming from deployment.status.available replicas. So it will deploy the deployment and then copy the value of the status, the value of the conditions, and then the available replicas, and make it available in a status field in my application object. So that's why I have my conditions here and I have my deployment conditions here, right? And I also have my available replicas here, right? So I'm going to go ahead and show you what happens. So now remember that when we defined the application, we said the application itself has 3 fields and then it will generate some objects. Well, if I do get deployment, I will have a deployment called my app, which has 3 pods, because that's what I did in the replicas field. I said I want 3 pods. If I do a kubectl get services, I will have a service called my app-service. If you remember, in the service, I actually gave it a name, which is the schema.spec.name. So that's coming from the schema on the top. And then I just add or append a dash service. If I do kubectl kube control get ingress, and I have the same thing, my app-ingress, and it's here. So I have my ingress here, blah, blah, blah. And the name is this name here. So I get the schema.spec.name-ingress. And so by simply creating a simple, very straightforward resource graph definition, I made it possible for people to go from having to write all of this to deploy an application to literally 9 lines of code or configuration, right? So this is where platform engineering comes into play, because you as a platform engineer will be responsible for deploying those resource graph definitions. And then your developers can just deploy things by instantiating those objects, by creating an instance. Now, some questions that I anticipate, because I have had them before. If I go and update my RGD, will the existing objects get updated? No. So going back to the slides, so yeah, the examples here could be, as a platform admin / DevOps engineer, I create an object called web app RGD. So I define a resource graph definition called web app. In that web app, I can define my deployments and services, my Prometheus monitoring object, my service accounts, my buckets, my SQL, my IAM policies, pub subtopic, whatever you want to create. These are Google specific things, but they could also be, AWS or Azure or whatever. And then as a developer, I can just create an instance called web RGD that have a bunch of fields that I have to supply. I have to give values to the fields. And then something, in this particular case, an operator called KCC, will be responsible for provisioning all the cloud resources. The resources that are native to Kubernetes, so the deployments, the services, these will be created by Kubernetes itself because the controllers are inside the cluster, or are part of Kubernetes itself. But then all the cloud-specific resources will be created by an operator which is specific to my cloud provider. So in this case, Google is KCC, but could be ACK or ASO. I can actually go even further. I can use resource graph definitions to simplify how people provision Kubernetes resources. So let's take provision cloud resources. Sorry. So let's take an example. If you are deploying a Kubernetes cluster on Google Cloud or on Azure or on AWS, typically those are like this kind of offering. They have a lot of parameters, like tons of parameters, like a lot of, maybe hundreds of different options that you can choose. And if you as a platform admin do not want your teams to either be overwhelmed because they have to, go through a bunch of fields and figure out what the values are going to be, or sometimes you just don't want them actually to set some things. We can take a very concrete example. On Google Cloud, we support GKE auto updates. So it's a setting called auto update. You turn it on, and it will automatically update your cluster. And let's say that you as an admin, you don't want people to turn that off. Well, all you have to do is create an RGD that sets a default value for auto updates and do not let people change it, right? So the schema part, the part that you expose to the end user, you don't give them an option to set auto update there. So you remove that option, you set it in the actual resources section, and then you say auto update enabled, and then you're sure that no one can turn off auto updates, right? Yeah, that's basically it. I have actually one more example I can show you, but this is kind of specific to Google Cloud, so probably not going to make sense to a lot of you, but let me just show it to you anyway. Again, I'm not selling anything here. I'm just trying to show you how this can be used. So we created this resource graph definition that creates some buckets and creates an event and does a bunch of things. But you see here, for example, we called it this very convoluted long name. We set 4 parameters: a name, a workflow name, a location, and a project. And then if we go down to the section, you will see it's super long because we're creating absolutely every single cloud resource. So for this particular example, because we're wiring together a bunch of cloud resources to make an entire kind of thing work, there's a lot of IAM policies you have to set. There is a lot of things you have to do. So we're just actually making it simple. So by kind of hiding the specifics of how these things work under the resources section, a developer can just simply create a very simple instance that has just 4 parameters. And this will deploy a very complex architecture with multiple objects and multiple services interacting with each other and IAM policies and all that stuff out of the box. So I have a few departing thoughts before I open up for questions. KRO is still experimental. So the team is very much looking for feedback. You can go to kro.run or github.com/kro-run/kro to test it, install it, try it out, and provide feedback. And yeah, the 2 other departing thoughts are not for this kind of call. That's it for me. My name is Abdel. You have the QR code, which will take you to my LinkedIn if you want to connect with me. And we can take questions, I think.
Yes, I see some questions now. Okay, so the first one says, how operators are used? Can you explain a bit more?
I mean, you typically do not see operators or interact with them. You install an operator, unless you're building it, obviously, but you would install an operator and then you would use the CRD to trigger the operator. So that's not something that you would actually interact with when it's running inside the cluster. But an operator is the actual piece of code that will go and trigger the creation of the objects once a custom resource definition object is created.
Okay, thank you. Can we use Helm charts instead of customize?
Yeah, of course, you can use whatever you want. I mean, Kubernetes is open, so you don't have to use. I mean, I actually seen people that use both. They would use Helm and customize to make Helm easier. So yes, so the answer is yes.
Okay. What are the advantages of using a CRD application provisioned by KRO to deploy a set of deployment service or ingress versus just creating a Helm chart call application to deploy the same set of resources, deployment service and ingress?
Very good question. So there are many advantages. Um, First, let's talk about the obvious things. Helm is a very heavy system. You have tons of things created inside the cluster. And when you are deploying a Helm chart, unless you wrote it yourself, you don't necessarily know what that Helm chart does. And let's be very honest with ourselves. Most people don't actually look at the Helm charts. They find the Helm chart somewhere and they just go like Helm install, blah, and whatever, right? So when things goes bad, things get broken, you will have to troubleshoot that. And sometimes you might be deploying things you don't know where they're coming from. So that's the first thing. The second thing with Helm, if you want to, like, if you find a chart that you like and you need to change certain things, most of the time it means that you will have to clone that Helm chart and maintain it yourself, right? So that's actually technically more work for you versus just like using KRO to write a very simple CRD, right? These are the two things I can think of specifically to this question. But again, do not think of um, um, do not think of KRO as a replacement of Helm. It's just something you can optionally use. You don't have to replace Helm. If you already have Helm, just keep using Helm, right? Yeah, so that's all I have to say.
Hey, how is authentication handled? Say I want to deploy AI models to Azure OpenAI. How will Kubernetes log into Azure?
Yes. So that depends on the operator that you're using. So I don't know anything about Azure, so I cannot talk to Azure. But on Google Cloud, we use this thing called workload identity. So it is a way for you to map a Kubernetes service account to a Google service account, a Google Cloud service account, and then you put permissions on that service account. So that handles both authentication and authorization. Um, but you can ask yourself the question of how does Terraform get authentication? So whatever way or mean Terraform handles authentication, operators in Kubernetes can handle it. It's pretty much the same thing.
Thank you. We have more questions. Can I combine KRO and Argo CD?
Yes, you can. Yes. I mean, Argo CD is essentially a CI/CD pipeline. So you can combine both. Yes.
Can KRO replace tools such as Terraform, OpenTofu on one day?
That is the plan. That's what we're working towards. As I said at the end, it's still pretty much experimental. So we're still some features missing and figure things out. But eventually, at some point, yes, we will be able to replace something like like replace Terraform with OpenTofu. So this is a very good question, actually. I think that the reason why people might want to consider using using KRO is that if you are deploying things on Kubernetes, you don't want to be using two tools, one to manage infrastructure and one to manage applications. So KRO gives you that single interface, which is the Kubernetes interface, to do everything.
Awesome. Thank you. What is the advantage of KRO compared to Crossplane?
Very good question. Crossplane cannot create Kubernetes native objects. It has an operator to run the kubectl command line, but that sounds kind of like a hack to me. So the same way Terraform has a module to do kubectl apply, which also sounds like a hack to me. The simple question is that Crossplane was designed to create and manage cloud-based resources, while KRO can do both, can do cloud-based resources and Kubernetes native resources.
Thank you. Can you enforce naming conventions for the cloud resources that will be created?
Yes, you can. Yes. Using Cell, you can enforce the naming convention.
Doran says, is the RGD resource enable parameter usage in the schema?
Is the RGD resource enable parameter usage in the schema? No, not to my knowledge. So no. But there is actually a feature request to ask the possibility to add list of values to KRO. So don't let people just choose any random value for a specific input and provide the user with a list they can choose from.
Thank you. How does KRO handle dependencies between resources? For example, what happens if one resource fails to deploy?
It will just stop. It will not continue the deployment. So it uses the DAG to figure out the resources, the schema, the dependencies. The example I showed earlier, like using the deployment labels in the service. That's just the way it does it basically, and it will calculate the DAG and create a graph and then run through the graph to create the resources. And if the resources a resource failed to deploy, it will not progress, it will not create the next one. And when you kubectl describe your object, you will see that the reconciliation have failed. But it will continue trying to reconcile the object. So if you resolve the problem, if let's say, for example, it was an authentication problem, and you resolve that, it will just proceed with the creation of the resources.
How can we contribute to the KRO project?
Yeah, you just literally go to GitHub. I'm gonna go ahead and copy the link of this GitHub and leave it in the chat. So you go there and you can contribute.
Since KRO is in experimental mode, do you recommend it for production use? When can we expect GA release?
I do not recommend it for production because it's literally experimental. The GA is planned for early 2026. That's the roadmap for now.
I have another question. What is purpose of annotations and how does it work?
What is the purpose of annotations? I mean, annotations are typically a way in Kubernetes to pass information to an operator. So you write an annotation as a value, and then the operator will be looking for that value. So the example here that I gave, which I didn't show, I think the question is coming from here. Those two annotations here, what they do essentially is that, for example, this is an annotation that is for a pub sub enabling that says a deletion policy abundant. So when this resource will be created, it will have a deletion policy set to abandon, essentially. Maybe you can look at the better example here. Let's see, do we have any good examples, notations here? No. Okay, we don't have any good example. But literally, yeah. So literally, annotations are a way for you to pass information to the operator.
Perfect. For cloud resources, what benefits does KRO provide from Terraform resources or other AIC tools?
Yes.
For example, to spin up some AWS, I don't know what is that stands for, SQS.
Yes. So Terraform doesn't have reconciliation built in. If you want to use Terraform to reconcile objects, so reconciliation essentially means you run Terraform to create a bunch of objects, and then you went to your cloud platform and deleted those objects manually. And in order for Terraform to reconcile, you have to rerun Terraform one more time. Kubernetes has built-in reconciliation. So in the event of somebody deleting an object in the cloud platform that should not have been deleted, Kubernetes will automatically trigger a reconciliation and recreate it for you.
Does any of these operators typically run as some kind of cluster admin, or does that solely depends on, for example, if you work in one namespace or across multiple?
I will have to read that question one more time. Let me find it. Okay. Does one of these operators typically run as some kind of cluster admin, or on example, if you work on one sim across multiple? Um, I mean, you typically need a management cluster. I think the word we use is management cluster, not a cluster admin. But yes, you will have to have a centralized management cluster to run the operators in. Um, and that typically is the cluster where you, as the platform engineer, will manage, install the operators, install all the CRDs. And then your developers might use something like Argo CD to just like provision a resource by creating a YAML file that gets applied to that cluster, and then it triggers the creation of the objects.
Thank you. Does KRO also set owner's references on the resources it creates?
Yes, it's the resources will be annotated with a bunch of annotation, and one of them is managed by KRO. So you would know when you query the objects if this object was created by KRO, created by user.
Thanks. Is there anything similar to KRO in the market at the moment?
No, it is a very unique project. It's the only thing that does what it does. So I don't, to my knowledge, to the best of my knowledge, again, I don't know everything. There is nothing similar.
Does it also support integration to create GitHub Actions workflows, for example?
Not directly. You would have to have an operator that creates GitHub workflows, and then in that case, if you have them, then you can use KRO to manage them, but not directly.
Perfect. Can you wrap other CRDs with KRO?
Yes, you can. And actually, the example I showed earlier, that's literally what we are doing here. So this is the example where, let me show you more kind of better example. In the resources section of this, we are creating this object, and it's literally kind IAM policy member, and it has, so this is actually a CRD. So yes, you can.
Thanks. Can I deploy an app in another cluster than the one KRO is running in?
No, unfortunately not. So in that case, you will have to set KRO into a like an isolated namespace that only platform admins have access to, and then the rest will, everything else will be created in the same cluster. So no, it doesn't have multi-cluster capability today.
Thank you. Let me check. Let's imagine the following case. There is an RGD, an app created from it, Nginx, bucket DB policies. App is deployed. Now I need extra connection to another bucket to write there. What will be a better way to handle those exceptions?
That is a very good question. As it stands today, you will have to update the RGD to add extra stuff, and then update your object and redeploy it. I don't know if there is a plan for supporting migrations yet, but as of now, that's the only way you could just like add extra stuff, essentially.
Thanks. How does it support exceptions in configurations, use case that are not described in the resource graph?
Can you repeat the question one more time?
Yes. Andre is saying, how does it support exceptions in configurations, use cases that are not described in the resource graph when some extra is needed?
I mean, it depends. It will literally not let you create the object if things are missing in the object, right? So you can set the parameters to be optional, and you can also set them to have default values if you want to avoid this. But generally speaking, if people create an object and the object they're creating is missing certain fields, it will just not accept it because it doesn't, the object will not match the schema of the CRD.
Do we need to have config connector in the GKE to create cloud resources with KRO, or is it natively integrated in KRO?
Okay, so KRO and KCC are two different things. Kubernetes config connector is something you can use today without KRO. So you don't need KRO to use KCC, and you don't need KCC to use KRO. You can combine them to make your developer's life easier. But KCC itself, Kubernetes config connector for GKE, you can deploy it. It's open source and it's free to use, so you can just deploy it and then use KRO to build objects based on KCC.
Perfect. Yusuf is saying, can I deploy an app in another cluster than the one KRO is running in?
I think we already answered this question. No, but it doesn't have multi-cluster capability. I mean, it was probably the same question asked by another person.
Yes. Well, I think those are the questions. I mean, we are having a lot, so I'm trying to make sure we're responding them all. Okay, we have one here that is, what is the unique selling point compared to Helm and cross-plane providers compositions?
Compared to Helm, I think I already explained it. The selling point is that it's simpler and you know what you're doing, versus with Helm, you might install a chart that you don't know. Compared to Crossplane, I already answered it. It has support for Kubernetes native objects, which Crossplane doesn't.
Thank you. So can KRO provision AWS resources like RDS?
Yes. So in that case, you would need to use I think they call it ACK, Amazon config Kubernetes. I don't know what ACK stands for actually. But yes, you will have to use the same thing. AWS controllers for Kubernetes. So you need to install this, and this will be the thing that will be used to create RDS resources or SQS or S3 buckets or whatever. And then you use KRO to like wrap those objects with, essentially.
Thank you. Yeah, so we are running out of time now. Thank you, Abdel. Thank you, everyone who joined. If we did miss your question, please just make sure to send it in the Slack. I shared the link on the chat. But yeah, thank you, everyone. We will send the email tomorrow with the link for the video and as well for the slides. Thank you.
Thank you, folks.